Okay, thank you very much, George. Yeah, good afternoon, everyone. It's my great pleasure to be here in London, and I'm very happy to talk about our project on interlaboratory comparison. So let's start. So this is on interlaboratory comparison on the measurement of temporal light modulation. Myself and Steve are the co-chairs of this project. And this is a collaboration with several other members of our core team. And so let's start. So as Niels introduced, we have used to be SSL Annex, and we've been active since 2010. I'm active since then, long time, and so we always have had a task on testing, SSL testing, and the major work in SSL testing has been interlaboratory comparison. So we had two major comparisons in the past. In first one, IC 2013. This is the very first one, interlaboratory comparison on measurement of SSL products. And we had, this became very large comparison, 54 labs participated, and then we had linked labs and total 110 labs compared. It's a really very large, big effort. And but this time we compared LED lamps and luminous flux, color quantities, and so forth. And this was designed as proficiency test to meet the needs for accreditation. And then next one, IC 2017, was on gonio-photometer comparison. And this one turned out very big efforts too. We had 36 labs, 42 gonio photometers. You can imagine, we had lots of data. And so they measured the LED luminaires and compared 15 quantities measurement results. And this one also designed as a proficiency test. And so we have a very detailed final report. So links are there. If I think these will be posted, Mike, after presentation. And so the third one, which we are running now, is IC 2023, or measurement of temporal light modulation. And the background shown here that the temporal light modulation of LED product causes flicker and stroboscopic effects, and depending on the level, it may cause negative health effects or discomfort or traffic safety concerns. So since 2021, the EU eco-design regulation enforced requirements for the TLM quantities. Actually, it's a PSTLM, called the PSTLM and SVM, which are shown at the bottom of the slides. These are in IEC technical reports. And so these numbers must be, as shown here, less than 1 or 0.9. And this is applied for all products sold in Europe. So it's been very critical requirement. And so since then, so other regulatory programs also added requirements for TLM quantities for some products. And so recently there have been very strong needs for the measurement assurance and testing accreditation for TLM quantities. So with this background, we decided to start the interlaboratory comparison on measurement of TLM quantities. So the objectives of IC 2023 are first to provide a technical study, so to investigate the level of agreement or disagreement in measurements of temporal light modulation quantities. In particular, these two quantities used in eco-design regulation. And second, provide a proficiency test for measurement of especially these two quantities for accreditation programs. And the third, promote a harmonized accurate measurement of TLM quantities globally, and hopefully improve some aspects on these metrics. And so this shows the outline of the IC 2023. So the instruments for TLM, so there are several commercially available instruments. And also some labs use their own custom-made instruments. So all of these are accepted for our comparison. And the artifacts, we used 4 different LED lamps and TLM generator source. And test methods are those IEC technical reports, and also the CA technical note 12 for the data sampling and measurement. And target participants. So we consider the testing labs, lighting manufacturers or instrument manufacturers, or the research laboratories, or whoever deal with the measurement of TLM. And then this comparison was linked with MET-TLM, which is a European metrology project. So they run a TLM measurement comparison. Also the China GBVLC comparison of TLM measurement. And so measurement quantities are those two important ones, PSTLM and SPM. And also we include the 3 other quantities. So we launched IC 2023 in September last year. And we published this technical protocol document. And this document provided the details of comparison scheme or artifacts, measurement quantities, test methods, data analysis, and many other details. And this document is published at this link. And so the participants, each participant paid these fees because it was really lots of efforts on the side of our pilot laboratories. And so we had 18 labs and 19 instruments participating in this comparison. And half of them participated in the TLM generator comparison. And so measurement round started beginning of this year, and the measurement rounds finished some time ago. And so we're still working on a lot of data analysis. The scheme of IC 2023 are shown here. So the measurements are the star type comparison, as you can see on the figure there. And so we have a Nucleus laboratories, which is the pilot lab that deal with measurement with all participants. The main Nucleus lab is a KIEL, K-I-E-L Institute in Korea. There used to be a KILT, sorry, I think it's not shown here, KILT. And then, so they dealt with all the measurements using the distributing the lamps. And also Denmark University of Technology, DTU. So they managed the comparison of TLM generator. We also had a supporting Nucleus laboratories. So they did not deal with participants, but established together the reference values. So they are National Institute of Standards and Technology in USA, that's my lab, and also National Lighting Testing Center, NLTC in China. And then, as I mentioned, we had links with MET-TLM and China GBVLC comparison. So we have link laboratories for those regional comparisons. One is DTU for MET-TLM, and NLTC also served as a link lab for this China TLM comparison. And so this illustrates the structure of the IC 2023. So the black circle below the main measurement round of IC 2023. And so Q served as the Nucleus lab for the lamps. And then DTU served as a Nucleus lab for the TLM generator. And then above there, the red circle is the Nucleus lab comparison. So you can see NIST, DTU, NLTC, and Everfine also second link lab for the China comparison, and Q. So these 5 labs made a comparison prior to the main rounds. And so we established the reference values for each artifact lamp types. And then the blue circle is the MET-TLM comparison. And then the purple one on the right is the China GBVLC comparison. And so each one, I think MET-TLM about 10 participants. I think they are only the MET-TLM members. In China comparison, I think they had like, I don't know, 18 or so, Mike, participants. But we don't know still the details yet. So, so this is the overall picture of our whole activity in this IC 2023. And this shows the measurement quantities. So the first one, the PSTLM and the SVM, these two are for proficiency test and technical study. And the right ones, the 4 quantities shown there are for technical study. And so actually the first 2, the PSTLM and the SVM, the results of these will serve for the purpose of proficiency test. And so we also asked the participants to report all of these below the measurement conditions, including the sampling frequency and the measurement duration, and all other information. Okay, so this shows the comparison artifacts. So we used these 4 different LED lamps. We labeled Art1, Art2, 3, 4. And so these are the specification of these LED lamps. And so actually we tested many lamps, before we decided to use those. So we tested the stability and reproducibility, and we tried to use a different values range of the PST, LM, and SPM, also different waveforms. We tested many things. Took a long time to actually finally pick those 4 lamps. And still, we couldn't find lamps with high PSTLM. So all of these actually less than 0.2. And so actually, I think most of those products in the market don't have high PSTLM values, which we found. But SVM can be high values. And the last one, Art5, is the waveform generator shown here. So, so we could create the different waveforms, whichever waveform we wanted. And this can cover the range of the PST or SPM values, which we could not include in the lamps. So again, we did a lot of testing and we found this instrument very reproducible and stable. So we decided to use it. And so we set these 5 waveforms for the comparison technical study. And so first one, the sine wave, and second one, PWM wave, and slightly different frequency than exact 120 or 100 Hertz, just for testing purposes. Third one, multiple low frequency components. So you can see it's a complicated waveform. Number 4 is for the PWM wave at 500 Hertz. It's pretty high frequency, but it's still within the range of SVM. And this can test the effect of the anti-aliasing filters used. Number 5 is a mixture of multiple frequency sine waves. Oh, sorry, did I disconnect the cable? Would it be for online? Sorry. Yeah, sorry about that. Okay, so I hope we are back on the audio. Okay, so these are the 5 waveforms we used, and the data analysis. So it's just a very summary of the analysis that we calculated the differences, the result of each laboratory of each quantity minus reference value. And then Z prime score and EN number. So these 2 are commonly used for the proficiency test. And so we use those for the data analysis and comparison reports. So, so we will issue these reports after completion of this comparison. The first one, Nucleus lab comparison report, which we will issue very soon. This shows all the details of the Nucleus lab comparison. I can show you some results soon, later. And then the individual test reports we issue to each participant laboratory with the details of their results only. And then we will publish a final report, which will present all the results of all the participants in anonymous manner. And this will serve as a technical study, the reference for all the details of this comparison. And so I'd like to talk more about the Nucleus laboratory comparison. So the purpose is to establish reference values for each artifact. And then second, provide the link to regional comparisons. And then third, check possible problems in the comparison protocol. Because we use the same comparison protocol as a test method, as shown next. And so if there are any problems, then we could identify. And the participants were these 5 labs, or the Nucleus labs, operational or supporting Nucleus labs plus link labs. And so those 5 labs participated. And so this comparison, the measurements have been completed, and the data analysis mostly completed. And I'm happy to show you some results. So first shows overview. And so these plots show the absolute values measured by each lab. for each artifact. So just absolute value. So this doesn't give you any details, but all of these 5 quantities you can see. And the first one, PSTLM, if you can see the values there, it's fairly low, as I mentioned. We couldn't find the high PSTLM values for products. And there are some differences, variations, but the scale is very low, you can see. SVM, it's a big range. So you really don't see any variations because scale is a very large scale. Modulation depth and flicker index, so they also show very good agreement. And MP shows large variations, you can see. I'll come back to this later. And so second, we checked the reproducibility of pilot labs. So they measured twice, before and after shipping the lamps to each lab. And so this shows the difference between after minus before. So within period of, I think, 1 month or so period, how they reproduced. And so the figure above shows PSTLM, and you can see the differences are pretty small. And these bars show the uncertainty of the pilot, which is keel in this case. And the graph on the right shows the absolute values comparison of after and before. And so you can see the difference in these bars, but again, scale is fairly small for PSTLM. And on the other hand, SVM, again, the values are very high, big range, and the differences are fairly small compared to these absolute values. And so I think this one also looks very good. And just to mention that we don't use the relative percent because these values, PSTLM or SVM, can be 0. So if the value can be 0, we cannot use relative percent, you can imagine. So yeah, we tend to look at both of these absolute values and then absolute differences. Next, so this graph on the left is an example of the difference between the laboratory and pilot. And in this case, just an example of DTU and pilot keel. And so these are just a comparison with pilot. So it does not mean this is the reference value, it's just a pilot value. And so these bars in this graph are the uncertainties of the lab, DTU in this case. And so we can see that the variations, and here's a scale, and the uncertainty, the bars, length of bars are overlapping mostly, and this looks a reasonable results. And right side is SVM. And this also same story, that this looks very good. So just one example, we have many of those graphs. Next, comparison of all the labs. And so you can see, again, left side is a PSTLM, right side SVM. And so you can see Art1, first group Art1, Art2, 3, 4, and then for each labs. And these red dashed lines are the uncertainty of the mean, because we calculate a simple mean and calculate the uncertainty based on the uncertainty of each lab. So these red dashed lines are the results of the uncertainty of the mean of the results in each artifact group. And so if all the points are within this range, then it's a consistent. And you can see in most cases, that's the case that, so add to the uncertainty of the mean is large, but the other points are within this range. So this is okay. Just the uncertainty of this mean is large in this case. And that's 3, add 4. Right side, SBM, very similar. Just 1 point. So there's some cases it's a little bit off, but I think overall it's a very good agreement within the range of the uncertainty of the mean. And then we found a couple problems in our data analysis. And the first one in PSTLM. And the right side, this is the one I just showed you, but this is not the first result. The very first results are shown in the left. You can see we saw much larger variations in our first results, up to nearly 0.2. And this is another lab, 0.13 or 4. And then, so this was really very significant variations. We started the investigation. Yes? Okay, fine, thank you. Yeah, investigation. And so some of us looked at the power supply, the tested different power supplies, and then bingo, we really got the very different results. So right side, the Kiel and DTU, so this one, Kiel and DTU changed their power supplies. And then the results changed a lot. This was really dramatic change. And so we accepted this as our final results. But there was this problem we found. And then since then, we started a full investigation on this power supply problems. And so actually, they all use the high quality power supplies, you know, expensive ones. And it's really amazing that those power supplies made difference. And so much further details will be shown and discussed in the next talk by Carsten. So I'll stop talking about this. And next problem we found was in MP. And so MP, if you're not familiar, it's another metric for flicker, similar to PSTLM. And it was published in the US. And so MP needs only 2 seconds or 5 seconds, the measurement time, compared to PSTLM, which requires 180 seconds, 3 minutes. So, so anyway, many people think the PSTLM 180 seconds is not reasonable. So anyway, MP has some attention, much attention in US and some other. So that's why we included MP in our comparison. And many commercial instruments also include MP as their output. So anyway, we found MP reproducibility very poor. You can see up to 0.5, and MP equals 1 is a threshold. So it's really very, very large variation, which we found not acceptable. And so the agreement also was very poor. And so in particular, we started a lot of investigation at NIST. And so we made some presentation, and actually we found some clues, what is causing this large variation. So yeah, we're close to submitting a paper in a journal. And so this is maybe last slide, George. So about the main rounds. So we are still in the middle of data analysis. I cannot show you the results of main rounds, but just, I really like to show you some preview of a result that, so the left side is the plots of the values for PSTLM for all the 19 instruments participated. SPM is the right side. And you can see PSTLM variation is very large. Just as we experienced in our Nucleus lab comparison, up to 0.5. SPM looks very good, I think, except a few labs. So this is just a preview, and we're working on detailed analysis, and we will publish final report in some months. So I'm finishing my presentation. So we really thank the Carsten and Mike and other members of our core team. We actually meet every week, 2 hours every week. So lots of meetings since I think last year. And so lots of work. We really thank all of them, and also the SSLC management committee. So I finished. Thank you very much.
Thank you very much, Yoshi. We have a few time for a couple of questions. Someone from the room. Otherwise, we have also people in the chat. You understood everything. That's fine. Excellent. Well, do we have some questions on the chat, Mike? Nothing? Okay. I think it's not the best time, just after the meal for questions. But very interesting, Yoshi. When do you expect to have the final report?
So I think late summer to fall, we try.
Okay.
The final report.
Yeah. Yes.
So you found issues with the power supplies, and you will discuss it later. I think that was an interesting observation. Did you have anything like that in the previous ICs? Problems with the power supplies, IC 2013 and 17?
In other comparison?
Yeah. Was that an issue at that time?
We didn't investigate. And of course, there was some indication that power supplies affected the results of all measurements of LED products, even luminance flux or color. But this was really very broad problems, and some people reported different results for different power supplies, but it's been very difficult. I think there have been a study in MET-TLM actually on power supply.
So this might be
for general measurement of LED products.
I'm just thinking this may be something that we overlooked for a long time.
Yeah, long time, exactly.
And
it came for this.
Require more investigation later on. I'm thinking about lighting systems, and you're coming into a building or whatever, and you have your driver and all that, but actually it's the fundamental power system that can also affect the lighting quality. Okay.
So I think Carsten will discuss more, but we try to find some solution or how to check the power supplies for this purpose. And so I leave to Carsten for that.
Okay, thanks, Yoshi. Any other question? Okay, I have one, which is rather provocative. Do you think that we have to push for a revision of the famous IEEE standard on flicker?
Revision of
the IEEE standard on flicker.
Standards on flicker.
Yeah. Do you think that we need to push to revise that standard.
So I think maybe Steve can say more about the two technical reports in IEC are being converted to standards with some revision. And so I don't know, I think we hope to provide some inputs on power supply problem, but we don't know yet.
Okay.
And for MP, we are working with original developer of MP, Andrew Bierman. And so we plan to make a proposal for revision of the assist document for MP. And so anyway, so Steve, I think you may have some comments on this.
Probably just very briefly, knowing what's going, we need to move on. But in terms of the IEEE, I think it is worth looking into, because that report 1797, if I remember rightly, something like that. It's most of the work that's reported in there is about single frequency or about dominant frequency. So it doesn't look at the commitment of products that have multiple frequencies within them and how to assess them. So the looking at the exposure level limits that are used there, it's for monochromatic or single frequency, single oscillation. So yes, I think it's an interesting document the way it was produced, but in terms of practicality with product, it's probably not very usable in its form.
Thanks, Steve. I will transfer that to Brad Lechman, but I know his answer. He don't want to touch any more that standard. Okay. Okay. Well.
Yeah. Sorry, I forgot to mention that CIE is working on a technical report on measurement. TC I think 289.
Okay. Thank you very much, Yoshi. Well, I think we can pass to the next speaker.